On Kobe, you can create your own custom content and share it with your students. And that includes auto-graded coding projects. In this video, I'll show you how to create a Python auto-grader question. First, navigate to the course where you want to add your content. There are two ways to do this. You can either click the See More button next to the course name, or click into the section, and then enable Edit Mode. From the left-hand menu, click to add a task page. From the unit view, expand to see the topics, then select Add Task Page. Let's give it a title, Python AutoGrader String Match Example. Here we have several content types to choose from. For this example, select Code. Enter the name of the task and choose the programming language, Python. Then select the question type, AutoGrade. Next, choose the AutoGrader method. There are two types of Python AutoGraders on Kobe. First is string match. This compares the student's printed output to the expected output. It requires a print statement. Second is test file. This uses the Python unit test library. It's great for testing functions and more complex logic. This tutorial will cover both, starting with the string match. Save. Here we have 3 panels. Let's collapse the left menu for more space. On the left, the Explorer panel is where you manage files and folders. You can create or delete files. There are 2 file sets you can work with. First is the question files. This is what your students will see and work with. Let me show you. Let's write a simple prompt. All code is automatically saved. Click Preview to see the student view. Next, the solution files. These are for your reference only. You can use them to test your project without affecting the student-facing code. Whatever you do with solution files won't affect the AutoGrader. The center panel is the code editor. On the right is where you insert the task prompt and set up the AutoGrader, and also enter hints and explanations for your students. In this example, we're going to ask the students to create a simple Python program that takes user input and outputs it in a certain format. I'll enter my prompt in the question box. Here, the user will be asked what their name is. Then, when the name is entered, we'll greet them with their name in this format. Hi, comma, space, name, exclamation mark. For example, when the program is executed, it'll immediately output, what's your name? Then the user enters their name, Jose, and the program will output, hi, comma, space, Jose, exclamation mark. Next, let's test out the solution code in the solution files mode. As mentioned previously, this is for your reference only to test your code. And here's the solution code. Let's test it out by clicking on the Run button. What's your name? Jose. Hi, Jose. Yes, we've got the output that we wanted. Next, let's design the student-facing side by switching to the question files. What I usually do is I copy the solution code and use part of it as a starter code for my students. Copy, go to question files, paste code. Remove what you want your students to figure out and insert instructions as needed. Or if you want your students to build everything from scratch, delete everything and simply enter just the instructions. Note that the main.py file is always executed first. Now let's set up the AutoGrader. This question takes user inputs, which will affect their outputs. So check the box for user inputs. When you run the AutoGrader, the inputs will be entered in real time, and the output and the expected output will be compared. Click on the +add button to add the test input and the corresponding output. You can add multiple test sets. You can copy the output from running your solution files, or since this is an easy one, I'll just type them in myself. Here's the first set. Input Jose. The expected output should be hi, comma, space, Jose, exclamation mark. And let's add another test. Input is Tara. The expected output should be hi, comma, space, Tara, exclamation mark. Then enter hints and explanations as needed. We can test our code right here. However, I want to simulate exactly what the students will see. So click on Preview. Enter the code. Run button here is for testing purposes. If you want to get graded, click Submit. Real-time grading. It worked. Our Python string match autograder is all set. Now, what if the project doesn't require any inputs? That's simple. Let's create an autograder task that asks students to develop a program that calculates the average score of the scores in a list. Here's the starter code. Note that the completed program must include a print statement. For this question, there's only one answer. Make sure the input box is unchecked. Enter the expected output, which is the average score, 86.6. Let's test it out by clicking on the Preview button. Submit to get graded, and yes, it's working. Next, let's create an autograder project that can handle more complex programs using Python unit test. First, create a task page. Unit, topic, then add task page. Let's give it a name. Python autograder unit test example. The type is code. Let's give it the same name as the page. The code type is Python. Question type, autograde. Method, test file. And save. Let's collapse the left menu. Much better. Here we have 3 panels. The Explorer panel is where you can manage your folders and files. Center is the code editor. The right panel is for adding prompts, hints, and explanations for your students. Let's take a closer look at the Explorer panel. You can add or remove files and folders. And you can also choose which set of files you want to work with. Question files will load up files that your students will be seeing and will be working with. So if you want to give your students starter code, then this is where you'll insert them. Also, students are not able to add new files, so they must be preloaded here. The solution files are for your reference. It's always a good practice to keep a set of solution code somewhere where you can reference easily. These files won't affect the grading process. Note that there are 2 Python files created for you. The main.py is executed first when the program runs. Grader.py file is used for grading and uses the unittest library. This file calls the methods created in main.py file. Here's the task that we're going to assign to our students. Create 2 functions, add and multiply. Each function should take 2 parameters. The parameters are 2 numbers. Add function should return the sum of 2 integers. Multiply should return the product of the 2 integers. The 2 numbers are processed and the resulting value is returned, not printed. For example, add 8,2 returns 10. Multiply 8,2 returns 16. Make sure to declare your function names add and multiply. Assigning these names is an important part of Python unit test autograder. We need to call the functions to test them, so their names in the task should be the same as what we use for the autograder. Before adding the starter code in the questions file set, you can begin by adding the full solution code in the solution file set. However, this is for your reference only, and we'll skip this stage in this tutorial. In the questions file set, main.py, let's enter what the students will see. Add comments or partial code so students can complete the rest on their own. Here we have instructions and 2 function signatures. You can have students create these from scratch also. Grader.py file is next. Note that the grader.py file uses Python unit test library, which allows you to create tests for all sorts of cases. If you want to know more about how to use the library extensively, search Python unit test. There's a sample code in the grader.py file that shows you some of the most popular Python unit test functions. In this example, we'll use AssertEqual. Here's the grader.py code for this task. It looks complicated at first, but it's pretty easy to work with. Let's look at the code line by line. Import unittest, main. The unittest library and the main.py files need to be imported so we can work with them. Class TestStringMethods. I'll skip the detailed explanations for this one. Just make sure to use this as is and to insert all test functions inside this class. Def test.add self. This function tests the add function. Note that you can declare the function name that suits your purpose. What's important is the next line, self.assertEqual. This function compares the two parameters and raises an error if they're not equal. In this example, the assertEqual function compares main.add 5,2 and 7. Note, we are calling the add function in the main.py file, so make sure to call main.add. If the function call doesn't return 7, it'll raise an error. Here's the second test. This function compares the return value from main.multiply 5,2 and 10. The last bit here, this line checks if the script is being run directly and it needs to remain as is. Now that the grader.py is set, let's test it out. Click Preview. Submit to grade. Yes, it worked. All set and good to go.